Well, hello there again, friends. Today is 5/27/2022, and today is the Odin Project Vlog Day 111. And I am on JavaScript Object-Oriented Principles, Object-Oriented Programming Principles, wow, OOP. And I am 25% complete with the JavaScript section. And today is a short video. There's a lot of good stuff here. It's not super long, but it does talk about the solid acronym, and I don't remember exactly what they all stand for. The first one is what they really hone in on, and really Odin wants you to really focus on, which stands for single responsibility principle, and we'll go over that here in the requirements at the bottom. So these aren't too bad of reads. Sub C here is actually a pretty beefy one. Take your time going through it. It's a kind of a longer read. Excuse me. It's kind of a longer read, but it's a really good read. Going into not just the single responsibility principle, but all of them in more detail. And so we'll go through the knowledge check again. I'm going to keep this video short and sweet, to the point. Sorry, excuse me, I've got a tickle in my throat. Okay. Alright, so the knowledge check, explain the single responsibility principle. And this is found in the text. As you craft your objects, one of the more important things to remember is the single responsibility principle, which states that a class or an object or module, you get the point, basically anything, should have only one responsibility. This doesn't mean that the object can only do one thing, but it does mean that everything an object does should be a part of one responsibility. That's a key thing to remember, and they go through different iterations of this thought of single responsibility means different things to different people, but a lot of people get it wrong, and they think that when they start thinking about single responsibility modules, particularly with discussion of variables and modules and functions, is that it only literally does one thing, and that's not really what they're trying to get at here. They're getting at really is that there's a single block of code that is responsible for one thing, and that's what it should be doing. So, you could have 10 lines of code doing different things, but they're all themed around one single thing, and that's kind of what the gist of it, how I understood it. So here's a really common example. Most of our code has functions to update and write things to the DOM in addition to our application logic. It's a really good idea to separate your DOM stuff from the application logic. So to give an example of probably spaghetti code that we've all done up to this point, which is you have a function called isGameOver, and then it calls another function inside there. And then, well, it doesn't call another function, excuse me. Inside of the isGameOver function, it calls a bunch of DOM manipulation, and they're just saying that this doesn't pass the single responsibility principle, and that you probably should move this out into its own module or its own section of code. And so that's kind of what they did here, even though it says you should extract all the DOM manipulation into its own module and use it like so. And so here's the function is game over, and inside here there's an if statement, and then it calls DOM stuff.gameOver. And this works. This does solve the S part of solid. However, even this, it says, in fact, the function is game over shouldn't be called in the DOM function anyway. That should go elsewhere directly into the game loop. I think they're referencing probably either rock, paper, scissors or not Etch-a-Sketch, but tic-tac-toe. But probably tic-tac-toe, since that's the most recent one we worked on for a game. And I agree with that, and I understand what they're saying. So here's your function logic for game over, and then your DOM probably should be not inside of function game over. It probably should be inside of its own module or inside the game loop. So that's that. And I'm not going to talk about loosely coupled objects. I think that's in one of the knowledge checks. So briefly explain the additional solid principles. So that goes out to this Medium article, and this is the really good one I was telling you about, but it does go on for quite a bit, and it builds on each other. So you don't want to skip around on this one. Follow it in order. But to answer the question is explain the additional solid principles. So I'm just going to briefly do that because that's essentially what the whole article does. So here's what it stands for. Single responsibility principle, which is what Odin wants us to hone in on. But the other ones are open-close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. And so we just went over single responsibility principle. I'm going to give a cursory just definition of this stuff. Highly encourage you to read it all on your own. So the open close principle, objects or entities should be open for extension but closed for modification. So basically that means that you should be able to go in and change objects or change entities or change anything in the extend that block of code without breaking it. If you do that and it ends up breaking the code, that means you have failed the open close principle, because you've broken the code. The existing code is what I'm saying. So closed for modification means that we should not introduce breaking changes to existing functionality because that would force you to refactor a lot of existing code. And that's the whole idea of the open close principle, is to help you, well, really, in essence, the whole solid methodology is trying to create more module code that is highly portable, extensible, and not easily broken. So that's kind of helps out with that. Again, there's a ton of examples about this. Functional composition. I just don't want to spend a whole bunch of time on this because it's pretty wordy. And there's a Liskov substitution principle. All this is stating is that every subclass or derived class should be substitutable for their base parent class. In other words, this simply means that a subclass should override the parent class method in a way that does not break functionality from a client's point of view. So basically, through this article and some of the other articles, Liskov and a Stack Overflow link that's in the reading, basically Liskov is you should be able to substitute and derive every variable. Like when you follow a variable through your code, it should not change scope or name or anything like that from beginning to end. And if it does, it probably will break functionality from the client's point of view, because it probably also, when it's doing that, it's not following the proper inheritance methods, parent class methods in here, as it says. But basically inheritance, either prototypical inheritance or not conclusion. What's the word that I'm looking for here? Functional composition. So again, I don't want to cover all that because that's basically reading the entire article, and I don't want to make this a long video. But basically, it's not Liskov substitution is you can substitute elements and ideas and logic within the variable, but it should stay in scope, and it should stay based on the parent-child relationship. And if it doesn't, then it breaks out and it breaks the functionality from the clients. And then they have a good example of the area calculator, but again, this is following, again, read this from top to bottom. Don't skip around because it won't make sense, because the area calculator and the volume calculator are covered above. And so I'm kind of jumping around here. So again, this is just cursory stuff. But interface segregation principle is a client should never be forced to implement an interface that doesn't use, or clients shouldn't be forced to depend on methods they do not use. That's exactly what it sounds like. So basically creating an interface so that the client only needs to use that particular method and not including creating interface that allows them to use those methods and not include things that they don't need. Because all it does is slows things down, makes the client slow on processing, and and takes up processor time, so and bandwidth, and it's just not necessary. And as you scale up your project, if you don't follow this principle, obviously it'll get slower and slower and slower, and just won't run optimally. More examples on that, obviously here. Really good article. Actually, I read through it twice because the first time I read it, I was kind of like, huh? So it's a lot of good stuff. And even after the second cursory read, I was still kind of like, huh? But we have a project coming up next, so called To Do. So I think it'll probably go through all this. So we'll get plenty of opportunity to practice solid principles. So. And then the D, the last one in solid, is dependency inversion principle. So this is entities must depend on abstractions, not on concretions. I don't know, whatever. It states that the high level module must not depend on the low level module, but they should depend on abstractions. So basically, not having your code in a way that one module is dependent upon the other. Like in our example from earlier, we talked about not calling DOM manipulation from inside a game over or is game over function, because that relies on, let's say for instance, the DOM manipulation was inside of its own module, but it was called from within the is game over. You don't want to do that because that's called dependency inversion. That's not dependency inversion, that's dependency version, and that means that those two modules depend on each other in order for the program to work. And if you remove one from the equation, the whole program crashes. So you don't want to do that. That's not best practice, and obviously will cause scalability issues and will break your code if you move anything around or change anything or refactor. It'll have to cause you to actually refactor a bunch of code. So, and they talk about high order functions. How is dependency inversion related to high order functions is a question asked in Stack Exchange if you want a deeper explanation, and they provide a link there that I won't go into, but you can go there if you'd like. And more examples here, and finishing out the reading. So there are a lot of good stuff in there. Oh, and I forgot. I spent too much time. I forgot there was a third one. Explain what tightly coupled objects are and why we want to avoid them. So actually it kind of ties in what I was just talking about with modules being called within each other. In fact, that's exactly what this is. So coupling is where you're using really anything, but modules is a good example, and probably variables as well, or not variables. Yeah, probably modules. Yep. Yeah, modules, because variables are private when you use them, so that's not an example. But modules, yeah, great example. So coupling exactly is what I was mentioning. So maybe I had my definitions wrong on the last on D, but coupling is where you have one module directly referencing another module. So in other words, one module knows about the other module. Excuse me, and you don't want to have what they call tightly coupled, and that's where one module, it's okay for the module to know about the other module, and that's what loose coupling stands for, and this article talks about all that and what the definition is. But basically, you would have a helper or a listener that is a module on itself that's listening for the input or something to happen in the other module for the opposite module to do something. Like, think of it as like putting something in a cart, and then cart goes, and then you go to check out the cart and buy the item. So that module, that in between module is like the listener, and it's listening for you to click check out on the cart, and then it hands the the rest of the program off to that second module, and then it listens for that to repeat itself all over again for a new customer. So that's kind of an example. When you couple too tightly, that's where instead of having the listener, you actually have the the cart example being called inside of the shopping cart, where when somebody clicks an item or whatever and they view it and then they click add to cart, well, then the code moves from add to cart to checkout. You don't want to do that because that's too tight, and if anything ever folds or fails in between that handoff, your whole program will crash because the whole program is reliant upon that handshake connection, if you will, to happen. So if that does not happen or doesn't happen correctly or in the right order or in the right speed, you're prone to having application crashes. So that's essentially what a very short version of coupling. And they talk about create order, patterns to reduce coupling. So they give you some. Here's the example of talking about tightly coupled modules, which is just talking about have a variety of disadvantages. And then they give you an example of estimated delivery using pub sub. I was thinking about this in my head when I was talking a little bit ago, but I didn't mention it. This is one way you can use a pub sub pattern in order to essentially do that listener idea I was just talking about. But instead of having a listener, you have a publisher and a subscriber, and they hand the data back and forth and the control back and forth so that it keeps everything succinct and running correctly, essentially, and one's not relying on the other to function, and so the program can flow. The code flows nicely, the program flows nicely, and there's not it's not so prone to errors and fatal errors, like application hangs, crashes, those sorts of things, memory leaks. And then there's a summary talking about the whole thing. I won't go into that, but yeah, so that's it. Well, a little bit longer than I wanted to. I always say it's going to be super short, then it doesn't, but it's not that long. It's important though, but I think we're going to get plenty of practice here in the module or the exercise project coming up here next time. So I'll probably be starting that this weekend. It's Friday night here at 7:15 p.m. So I'm going to call it for this video. So please like, share, and subscribe for more content. And let me know in the comments section what you guys think of OOP principles and all the stuff we talked about tonight. So with all that said, until next time, see ya.